Hello everyone. Always feel a bit odd when I start a stream because I'm never sure about whether it's all working and the levels are all good and I'm on the camera and all that sort of stuff, and whether my hair looks nice. But here we are, and tonight, I am pretty happy because it rained, and for the first time in months in Perth, it rained, so I'm ecstatic about that. I love the rain. And the other reason I'm pretty happy is that we're going to show you infills, but using a method I like to use to teach new engineers who are unsure about where they should put their infill hole. And it's a grid. Okay, it's pretty simple. Patterns are patterns. They're repetitive forms, and we should be aware of that. And that's the main purpose of a pattern, is like the word means, a repeating pattern and a repeating form of something. In our case, it's blast holes. And what comes along with a pattern is geometries. And so we're going to look at the various geometries that make our pattern, and will add to us making the right decision for where a blast hole goes. So I'm going to switch over the screen as you can see there, right? So we're in Paradigm again, and I am also going to show you it in the program that I wrote, and fingers crossed the program that I wrote doesn't crash or anything like that. It's still a bit buggy and not for deployment. So if anyone's wondering where you get that, you can't get that unless you want to invest hundreds and hundreds of thousands of dollars in me, and then I will hire someone else to fix it. Radio. Okay, so moving on, we've got this pattern here, and you can see a lot of lines on the screen. I'm going to zoom out in a second to show you what I've done, and it took a bit of time to do this in Paradigm, to offset the lines and get them all working so they lined up on the pattern. So if I zoom out, we can see what we've got there. And this is the old. So if we turn off these shapes, we can see what we've got is an old blast boundary there, and we've got these blast holes in there, and this is the same sort of file that we had last time. The surface here, I've simplified it a bit so the program runs a bit quicker, not as many triangles. So we've just got this blast, and those blast holes are obviously not snapped to the surface yet, so we can go back and ignore that. But what I want to show you is this concept of gridding, so that you can find out where you put an appropriate blast hole for an infill, if you're just doing a mine blast, or where you can move a blast hole to. And this is quite complex in this, in terms of what you're seeing on the screen, lots of lines. So I might show you it in my program that I wrote called LiteTie. So this is what I've got in LiteTie. I've got a pattern, I've got a blast boundary, I've got these holes that I didn't fit in my pattern, and some holes outside of the block area, and I've got these lines, and they're relatively simple. I don't have as many as the previous version, so that might be a bit of a problem there. But if we'll just zoom in, and it's pretty simple. Let's do these edge ones in this one here. So you've got hole 20 and hole 40, and we can see that we could just drag those holes in to here. And that may be suitable, but that's more of a line along this case. So if you were to want to do that, you would draw your line through here, and you would apply your geometry. So that's the line that one should move along. If you were inclined to move, just pull it back inside the blast, or if you were to keep it in line, like say you've got an access issue, so you want to drive out the truck out this way, then you'll slide that hole along the yellow line. Or you can slide that hole along the green line up to hole 30. So these are all just using geometry to give reason to how you want to move your blast hole. And so that it fits appropriately. But the good thing about gridding, and we'll show you this, is I'll turn on the floor RLs. Yeah, the floor RL, and we'll dial those up so that we can see the overlap and interaction. So this is sort of like where our blast is overlapped to, and we want to move our blast hole number 40 in, but we want to maintain this circle out here because that's where the blast hole should be, and we're expecting that there's some toe and stuff around here, or the angle of the face is down there. So we're really targeting the toe of the hole at this point. So for starters, let's select hole 40. Let's see if I can do that. Hole 40. I'll right click on, yeah, see too many bugs in it with the line. So let's go through this way. We'll turn it this way. So I'm on hole 40, and there it is there. And I want to, can I select it like that? Right click on it. Nope. So I will give it a angle. Let's see. Now we need to pick an angle that's appropriate. Maybe our drill rig is a big blast hole rig, so it can only do 5 or 10, 15. I only do 5 degree increments. Or maybe it's a small hole rig that has a very flexible mast that can, set any angle up. But let's say it's a big hole rig and it can only do 5 degrees. So let's say we just give it a 5, so an 85 degree angle. And we can see here, we better turn on the hole track just so we can see it, and we'll turn the blast hole size down a little. So you can see that it's slightly shifted off. And we'll grab that blast hole and I think we're going to, yeah, there we go. We're going to turn it. And so the angle here is up through there. It's, back that way is 61. So we're going to do it the opposite way. I'm just going to guesstimate it down there. Probably isn't quite in the right spot, but that's okay. We can move it a little bit when we line up the hole, and then we can grab the move tool. And oh, there you go. I've got all my blast holes there. All the stuff that's lining up. That's not good. Well, I did say it was buggy, so we will do it this way. And we can nudge it up or nudge it across, but I've already moved it and messed it up with all these lines, so we'll pick another blast hole to move, and I'll make sure that I can select only the holes. Yep, selecting only the hole, and then selecting the move tool, and now I can shift it across. Well, there you go, it's grabbed that line again. But you can see here the intent with all this gridding is that you can now see that where the toe should be. So at that point you can now influence the angle and dip. So I thought this would be a good place to show you this, but it obviously isn't, because I keep moving the lines. So we'll go back to Paradigm, which is a much more stable program, obviously, because probably a professional programmer wrote it. And we've got this this grid pattern down here, and what we might do is we might just delete the pattern here, and we're going to delete that, and we're going to add in a whole grid tool. Yep, that's everything that we want. Move that over here, and we're just going to move this blast across so that we fill it in with a whole bunch of things. And because we've got our grid, we know where everything is. Obviously I have got to I've got to add more rows to it. What do we have? Let's say it's 20 holes and 8 rows for the moment. Right. We might have to cancel that so that the 8 rows go on there again. Hole tool. And the reason why I'm using the grid tool at this point is because I wanted to show that if you design with more blast holes than what you need, you can move those blast holes in and out because they're already designed. Essentially, they might not be snapped to the surface, but that's okay. You can snap them in a moment. And we just delete the ones we don't want out, and if you're using an appropriate program, you would resequence them. Now that is coming up a bit odd because I'm not lined on my, there you go, I need to find my intersection. Like I said, I've got too many lines on it. Get that done. And as you can see, I probably should have moved it back there. How many mistakes am I going to make in one night? Plenty. I'm going to take this back again. So, but you can see the gridding that I've set up, I set up with a template and offsetted. So I just put in a few blast holes. And then I lined my grid up on this. Now, if you've got another program, let's say Vulkan or something like that, which I talk about a lot, Vulkan has a few more CAD features that are useful. And in this case, we're just going to say that's good. We've created those holes. We're going to close them off. That's just quite a few holes there. I don't like this color. I'm going to change them to white. And yeah. And we're going to white has disappeared. Oh no, I have turned it off. There you go. Easy. All right, and we're just going to turn off the extra features that are on there, so clean up the screen so that we don't have all these sorts of things. Now I've got several different lines on there. I've got a stagger, half stagger amount, which is the offset amount between rows. That's the yellow one. Let's see what we've got here. We've got this stagger row, which I can turn off. I've got my rows, which is along my rows, and I have got my echelons, right? So if we turn that off, I think I have the grid showing. Do I have the grid? No. Let's turn off the grid. Seems to have a bit of a problem with the graphics there, but that's okay. So what we've got is we've got all these blast holes there, and I'm going to turn off my hole centers there that I drew. And what we've got, so if we turn on the echelon, we can see all our holes are lining up with the echelons there, and if we turn up on the first echelon, that's the other way. And we've got the half stagger so that if we were to move a hole back through here, we can see it. And we've got the rows so we can move a hole back along there. So, and we've got these points. Wherever these two echelon points connect, that's where we know that the toe of the hole should be, okay? So if we were to take this particular hole here, which I was trying to show you before, Let me just make sure you can see that. We're going to move this blast hole back, and again we can use the collar to toe offset, so we would know that we could move that back and have a 5 degree, well it would be a certain amount out, yeah. So but let's turn on the hole toes so we can see the hole toes. We'll show hole toes, which you won't see because these are vertical holes. But if we were to take this blast hole here and we were to change it to an inclination of like what we discussed before, 5 degrees, we can see now our hole toe out there, and we can adjust our bearing because we want it to be the opposite way, so we line it up with this row line because we actually want the toe here where the hole is, and then we can get our move tool and we can move our blast hole along inside the boundary of our blast block and place our hole, and we know that we are hitting this point here with the majority of our energy, and that we're moving it back. So 5 degrees seems okay there. And it's the same with all these, like all these blast holes. So at this point here, so I finished the move tool, and we're going to grab the blast hole there, and we're going to give that a 5. So as you can see, this is like the reason why I haven't just designed inside the polygon and then adding infill holes afterwards, because I like to have excess holes and then move them around so that I make sure I've got the toes covered, the energy covered, because we want the toes to line up with the previous blast for cookie cutting reasons or something like that. Maybe there was a bit of crest back break. Anyway, so here we are, and what we're doing. Yeah, so our move tool, and this is essentially, see, we can see where this blast hole should be right on that point, the toe of it, so we can just line it up there, right? And that way we know that we've got our energy on that toe. Yeah, and this one maybe we don't need one, so we can delete that hole, this blast hole here. So we'll delete hole number 41, and you know, this one might have been in the previous blast, so we don't need an infill hole. So you can see here we don't actually need an infill hole for this area, because this one is taking care of this one. This one might have been in the previous blast adjacent to it. It's already blown up and gone. So so the gridding tool helps you to place the blast hole in the gridding method helps you place a blast hole in the correct location. So these ones all out here, we know they're outside our red line. We essentially don't need any of them in this area until we get around to here. So we'll just ignore those ones out there, and now we've got a bit of a gap in our blast of energy. So we can add in a 5 degree. Let's say we've got a bit of a crest issue and we need to put in a 10 degree hole. So we'll put in a 10 degree hole. Wow, that's a massive angle, isn't it? Massive increase. And then we take it out 180 from that. So I think it was negative 59. So it should be about, let's just go for, sorry, 21. Yeah, there you go. And we can then move this back to this point, so we can see we're just placing our toe there. Now this means that it might be difficult to drill, so a 10 degree hole might not be what you want in that case. So that's going to be too difficult to drill if you've got a drill cone that would fill up this adjacent hole. So we should consider that. So let's go back to 5 degrees, and we've got that space It's just about, just on the edge of our boundary, but we can get it and we target that toe line. So if we, so we're just using these lines and this grid tool to move our blast holes so that they fit into the stagger, or they fit into the echelon, or they fit into the, so that the toe is covered. And once we've done all those things, so if we turn off a few of these lines just so that we don't see so much junk on the screen. Yeah, we've got this. We've got this covered now. We've got these toes covered with this cross section, this looking, so we know that we're hitting the toe in the right spot there. We know we're hitting the toe in the right spot here. This one we don't need, it's inside our blast block. Here we go. So this is the only reason you're putting angle on these blast holes, is to hit the toe, to target the toe. So this one, really quite annoying that pops up all the time. So this one here is there, and that's okay, it's inside the block. Obviously the hole is not as big as that. This one's okay, these are all blasted, so we can ignore all them. We can ignore all them. Or say this was a back brake. Let's say this was back brake here and we needed to hit this target, this toe. So we can turn on our stagger, because that's the line that we're going to run it through. And we know that it's quite a big move, so we need 10 degrees because we're on a 12-meter bench, pretty much. So there we go, 10 degrees, and it was, what was it, 121 was the bearing. That puts it back out there. And so if we just can put on our rows as well, so that we row lines, and that way we can target that toe point right there. And that's where you want to put the blast hole, ideally. Now, if you had a couple of choices or angles that you could use, and you didn't like, if you didn't like the 5 degrees and the 10 degrees and that sort of stuff, then you could use something else. But you could, and you had a drill rig that had a mast that could do your 4 degrees or your 2 degrees, or I wouldn't do anything less than 5. It seems almost pointless. Even 5 is kind of pointless on short benches, like a 6-meter bench, angling blast holes. You're only talking about a meter max deviation on 10 degrees, so you need to, that crest to toe is only like a meter out. Is it really, you have to weigh up your choices, and you have to weigh up whether that's effective, because an angled hole in broken ground is almost impossible to drill. You might lose an entire string. So if you've got broken ground, angle holes is probably not something you want to do. Now where's all the broken ground going to be? Well, it's going to be on that interface of the previous blast. So that's something to consider when you're designing. That you don't want to be using angles if you don't need to in broken ground. If you've got like a quarry and it's a very firm rock, it's very uniform and it's not broken, then angle holes are fine. But they are more effort, they do deviate, and so they come at a cost, essentially. Now, you can do the same if you said, well, I just want to give it a bit of juice on the face. So you can use the same mentality there and not even angle it, and just say, well, I don't want to angle, I don't need to angle, but I know the hole needs to go back along that line. That's in the line of the stagger, so that's the case. But then perhaps you have, like on this side here, you've got a face that's cutting down the echelon. Well, perhaps you want to use the echelon to move your infill hole in on the echelon, so that you take it up the echelon. There, sounds a bit off. Or you can take it back on the cross-sectional stagger, but you'd need to draw a line there, and well, you don't need to draw a line, but you could imagine a line through here. So all this gridding does is give you a reference point to to place a blast hole in an appropriately geometrically correct place. It's pretty simple concept, and for people that don't, like people who are learning drill and blast engineering or starting up and they go, well, I don't know where to put the infill holes. Like, where should I put the infill holes? Well, put them along the lines. It's really that simple. Keep the pattern repetitive. Keep your form and your adjustments to it with method, and have a purpose for each one of these blast holes. I apologize about the previous program, even though I thought it was going to be really cool to look at, you know, and be really cool to show you. Show you my little application here that I had, but all the lines make it very difficult to show you. So maybe I can clear the entire thing. Select all in holes, select all holes, or maybe just select, yeah, okay, and so we'll going to put a little boundary in here. Let's draw a little boundary through here. We'll go into a boundary and we'll close it. Turn this stuff here transparent. Okay, rightio. Oops, adding points everywhere. Well, let's delete that point. Let me see if I can delete that point. Got to remember my own program. Haha. But there you go. Sort of, that was essentially what I was going to do. Here we can select a point on the boundary. There, we'll grab that and use a reference point down, maybe down here. I'm not sure if this will work. Yeah, that failed because I don't have a point there, so I will draw a point out here. Rightio. We'll try that again. I'm using this back line as a reference point, and then this is my starting point. There you go. There's my blast with my toes inside the polygon, and now you can sort of like see what you need to do there. So let's I'll zoom in on that section, and so if we were to select this hole, I think I'm going to have a lot of problems. It seems to be selecting everything, so I will select only holes. There you go, that one. We will move it, and this is essentially what we're going to do. We can see our overlap where our hole used to be, and now we're going to move our blast into here, but then we will want to target that blast hole and give it an angle and kick it out. Anyway, it's clearly not working the way I expected. Once we've drawn this boundary, I can probably get rid of it. Yeah. Let's delete it. Maybe that will work a bit better. So now I can select blast holes because my program, as I said, is not great. 80 degrees, and then we can see where we are at. We can even turn on these reference lines, and we'll select the rotate tool, and we can rotate it out so that we're not getting our overlap. So essentially that's what you're looking for. So this is a toe of the blast, and we want that overlap. So you're just using these as sort of reference points to see what sort of energy you're maintaining at the toe, if you can, and that's what you're thinking about. So you're aiming for this toe line, and you'll find that would be pretty close to where that toe line should be. So if we just draw a line quickly through here, well, that's, yeah, that looks, see how it lines up with 33, 24, and now the toe of 15 roughly, and then we can go over here and grab 17 through to 16, and yeah, so so we can see that it's lining up on these points. So that was what I was trying to get at, is like if you design off the collar, you can project out from the toe. Now, if you're a person that designs off the toe and projects up to the surface, you might not have any of these problems, because the hole will just extend to the surface. I think it's pretty simple. I thought I would just show you that, and it's going to be one of the last things I kind of show you for a while. I have another opportunity, and it might take up some of my time. So I'm hoping that I can continue with these videos maybe once a week or once every 2 weeks. So I'm thinking I might be able to do a blasting video on some kind of concept once every 2 weeks, every week. But for a few months there, I'm going to be doing something else. So I'm not sure how often, but I've got to take opportunities when they come along. So I'm going to take this one. And I hope that you all enjoyed this as a concept. And you can see, and if I turn off these blast holes there and put the screen back on, you can see the gridding method. You know, you just got this grid. So if you're concerned about where you put a infill hole and you want some logical reason for moving it, then move it along those lines. So you slide it up the echelon line, or slide it up the reverse echelon line, or slide it along the spacing, or slide it back through the stagger of the pattern. If it's a rectangle, then you don't have as many problems. So these are reasons or methodologies for moving your infill holes, because a lot of people just say, oh, put them where you like. Well, you need a reason, and the reason is hit the toe, target the toe. Move them where you like, but target the toe. Then the other consideration is, once you've targeted the toe, is to allow for access for trucks to move through, or all sorts of things, or water carts, or re-accessing for drill rigs and re-drills. So all these considerations is good to think ahead of time, and to have the consciousness to think about the problem that you might encounter, so that you can plan for possible events. And you're the designer or the engineer, so you build a bridge with 3 bolts and you expect 3 bolts placed in it. So if you think about the penultimate design, the ultimate design that you want to achieve, and you then all you're asking is for your carpenters and your builders and your bricklayers and your roofers to place the piece of equipment, or place the bolt where you told them to put the bolt. And that's essentially what they do with bridges, and that way the engineer's to blame. So the best thing is you do a good design and you'll look after everyone. But I really appreciate everyone that's been watching the videos, and I hope that they're of use. And if you like the videos, then please subscribe. But as I said, they're going to be a bit slower coming than previously. I was trying to do 1 or 2 or 3 a week, or even 2 a week. I won't have that sort of time available to me for a couple of months, so I think that I will be just trying to get one done on the weekend, or once every fortnight. I'm interested to know whether what type of concept you want me to talk about. Or if you want to share a concept that you guys out there in the wider world do that you find really useful, I'm happy to have a play with that concept and understand it myself. And you're always learning, so I'm 27 years young in Drill and Blast, so you're always learning. So that's about it for tonight. It's a really quick 35-minute stream. It was just really about this grid and making it work. So one more time to show you that, and just target the toes. So I hope that you have all enjoyed my videos, and I hope that I have some time to make some more. But thank you very much once again. I'm rambling now, so I'm going to tune out and turn off, and have a good night. Everyone, take care, be kind to each other.